Hi guys, welcome back to my channel. This is Karthik from Karthik's Tech Time. This video teach you how to set up K++ V2 autopilot system for your agriculture sprayer drone. First, open K++ assistant software and then connect K++ autopilot system through USB cable. K++ flight control software includes 4 functional interfaces: overview, basic function, advanced functions, and tools. In the overview interface is mainly used for read and view the existing parameters. It can detect the basic parameters of flight controls, installation data of the airframe, main parameters of the remote control, aircraft sensitivity, battery voltage protection parameters, and the connections of the expansion module. In the basic interface, it includes frame selection, installation direction setting, power configuration setting, remote controller parameter settings, sensor data reading and calibration, and finally flight parameter settings and functions. Then advanced function interface. It includes advanced gain sensitivity, protection functions, pump settings, level gauges, then plant protection functions, fence modules, and expansion modules. In the tools interface is mainly used for upgrading flight control firmware, restoring factory setting, import and export the existing parameter, downloading flight logs, go back to the basic function settings of K++ V2 autopilot system. First one is frame selection. Select the correct frame according to the flight control aircraft. The direction of the orange color arm in the picture is the nose of the aircraft. Next, installation setting. Choose the correct orientation according to the actual installation direction of the flight controller and GPS. First one is IMU orientation. The direction of the IMU is the installation direction of the flight controller. The red arrow facing the IMU indicates nose direction, and the gray arrow on the flight controller indicates the direction of the actual flight controller. Next, GPS orientation. The red arrow of the GPS direction indicates the nose direction, and the black arrow of the GPS indicates the actual GPS direction. Please ensure that the GPS direction is consistent with the actual GPS installation direction. If you are using dual GPS module, please ensure that the two GPS installation direction are the same. Next, IMU location. According to the distance between the flight controller and the center of gravity of the drone, we should fill in the IMU installation position X, Y, and Z axis correctly. Next, Power configuration. Power configuration, it includes basic sensitivity, motor idle speed selection, and motor sequence. In the basic sensitivity setting, it includes roll correction, roll damping, pitch correction, pitch damping, yaw, and vertical. Let me explain one by one. Roll and pitch correction. It is used to adjust the attitude control adapted to the drone. If the aircraft attitude is weak, it should be increased. If the movement is stiff or overstated, it should be adjusted down. Next, roll damping and pitch damping. It is used to adjust the attitude control of the drone to resist external disturbance. For example, if the aircraft attitude is high frequency jitter, it should be adjusted down. If the movement of the drone is stiff and overstated, it should be adjusted little bit higher. Then yaw. This parameter is used to adjust the yaw control of the adapted drone. Then vertical. This gain is used to adjust the height control of the drone. Then motor idle speed indication selection. It is used to set the ideal speed of the motor after when the drone is armed. Off means do not rotate. Very slow, it should rotate very slowly, and slow it rotates slowly, and medium the motors start rotating in the medium speed, and the last one is fast. So slow is recommended for any kind of agriculture drone. Next one is motor sequence. This function is used to test the motors M1, M2, M3, M4, M5 and M6. Next, remote control setting. First one, RC type. K++ V2 autopilot system currently support S-bus and PPM type receiver. And second one is remote control calibration. Click the RC calibration button to initiate the joystick calibration. Move all the joystick of the remote controller between maximum and minimum position, and we have to confirm the remote controller channel 1 for roll, channel 2 for pitch, channel 3 for throttle, and channel 4 for yaw. Next, flight mode setting. Channel 5 of the remote controller are used to map the flight mode. There are 3 flight mode can be set in the K++ autopilot system. First one is attitude mode. Second one is manual mode. Third one is attitude mode or AV operation mode. Whichever it is required for your operation, we can set it. Next, failsafe. That is called as runaway protection setting. Runaway protection setting is used to set the flight behavior of the remote controller when it is out of control. It includes auto return, automatic return, automatic land, automatic hovering, landing after hovering. So the recommended setting is automatic return. Then finally failsafe continue working. When the out of control continue operation option is enabled, the out of control protection will not be performed after the remote controller is out of control in the operation modes such as AB operation mode, root operations, but the operation task will continue to be performed. Next, sensors. Check the IMU and GPS sensor parameters and do accelerometer calibration and magnetic compass calibration. First one is IMU calibration. Place the drone horizontally and click the IMU horizontal calibration button. Calibration will be completed after 3 seconds. Next, magnetic compass calibration. For compass calibration, we should rotate horizontally clockwise direction and then vertically clockwise direction in order to complete the compass calibration. For example, when the flying field changes, the magnetic compass calibration need to be do again. It should be recalibrate again. Before calibration, please check if there is strong magnetic interference nearby. Next, flight parameters. We need to set the aircraft flight speed related parameter according to the actual model and operating environment. Speed damp, that means maximum tilt angle in all flight mode. Maximum ascent speed, it is maximum ascent speed that pilot can control, and maximum descent speed, that means maximum descent speed that the pilot can control, and maximum flight speed, it is maximum horizontal speed in attitude mode as well as GPS mode. Next, advanced function settings of K++ V2 autopilot system. It includes advanced gain, that is advanced sensitivity, protection functions, pump setting, level gauges, and plant protection functions, then output fence modules and expansion modules. First one is advanced gain, that is called advanced sensitivity. It includes control gains of pitch and roll, yaw axis, vertical, airline, brake sensitivity, takeoff sensitivity, maneuvering sensitivity, and coordination. Let me explain in detail about control sensitivity. First, control gain of roll and pitch. It adjusts the control feel of controlling the pitch and roll movement. Next, yaw gain. It adjusts the control feel of controlling the yaw sensitivity. Next, vertical. It controls the feel of adjusting control height during takeoff and landing. Then airline, it is called route. It adjusts the acceleration and the deceleration speed of the aircraft during autonomous flight. The larger value, it responds faster. The smaller value, the aircraft movement is smoother. Next, brake. It adjusts the speed of the aircraft when braking autonomously. The larger value, it brakes faster, and the smaller value, it brakes slower and smoother. Next, takeoff. Adjust the takeoff response of the aircraft. In simple, the larger value, it takes off very faster, and the smaller value, it takes off smoother. And maneuvering, it adjusts the acceleration and the deceleration speed of the aircraft. In general, this adjustment is not recommended. Coordination. It is used to adapt the coordination degree of control in terms of response and aircraft maneuver. Next, speed gain sensitivity. Horizontal, that is called level. The gain of the aircraft in horizontal speed control, which is generally not recommended. Next, vertical. If the vertical base sensitivity is adjusted very low level, it occurs high twitching. So it is not recommended to change the value. Finally, attitude. This attitude sensitivity is also called as spiritual sensitivity. It adjusts the speed of flight control response in terms of input command of the remote controller. Next, performance mode. This performance mode is mainly used to adapt to different type of frames. If flight instability occurs, in different performance mode can be adjusted to achieve stable flight results. Then third one is performance orientation. In simple, if the aircraft appears jittering or the motor output noise is larger, the performance can be adjusted to suppress vibration. It is not recommended to adjust this parameter when the aircraft does not shake very much. Next one is protection function. This protection functions includes low voltage protection type, PMU fault protection type, set alarm volt, implement voltage calibration, and finally set one touch return function. First one is low voltage protection. In K++ V2 autopilot system detects battery voltage through power module and it provides low voltage protection. This flight controller provides 6 low voltage protection behavior, that is no action, that means none, pump stop, that means pump off, stop and return, that means pump off and it returns, stop and hover, that means pump off and it hovers, stop, hover and land, that means pump off, landing after hovering, and stop and hover, stop and land, that means pump off and landing. Stop and return is the recommended setting for this particular agriculture sprayer drone. Next one is PMU fault protection type. This flight controller provides 5 type of PMU fault protection behavior, that is close, that means shutdown, landing, return to home, stop, that means hovering, stop then land, that means landing after hover. Third one is alarm voltage. Set the value of the primary alarm voltage and secondary alarm voltage. When the battery voltage detects the flight controller reaches the first level alarm voltage, the flight controller LED flashes yellow 3 times. When the detection voltage reaches the second level protection, the yellow light flashes quickly and the flight controller will trigger the low voltage protection behavior which is set by the user. Then calibration voltage. When the flight control detects voltage is different from the actual battery voltage, this measurement of voltage needs to be calibrated. We need to enter the actual voltage of the battery in the measured voltage. In order to calibrate the flight control voltage, make sure the current voltage displayed by the flight controller is consistent with the actual battery voltage. Next, one touch return. This is the altitude when returning with one touch, and this is the speed it return home landing. When setting the return altitude, please set a reasonable altitude in accordance with the current flight environment in order to avoid obstacles during the return journey. Next, pump setting. Pump type, single pump or double pump. If we are using single pump, we should connect the corresponding signal wire to the P1 port. If we are using double pump, we should connect the corresponding signal wire to P1 and P2 port. In dual pump mode, the forward movement of the aircraft is controlled by P1 port and the backward movement of the aircraft is controlled by P2 port. Next, channel setting. It is used to select the channel that the remote control controls the pump. The default channel is 10. Next, liquid level gauge. It includes type of level gauge, current level gauge status, and the drug protection setting. First one is liquid type. The switch level gauge needs to be connected to the flight controller L1 port. Current level gauge. Refresh the level gauge status in real time. Then drug protection. The K++ V2 autopilot system has 5 kinds of drug protection behavior. First one is no action, that means none. Second one is stop pump, that means pump off. Third one is stop and return, that means pump off and return. Fourth one is stop and hover, that means pump off and hover. And last, stop hover after land, that means pump off and land after hovering. User can choose according to their needs. Next, plant protection setting. Use sideways, that means U-shaped lateral movement. By default, it should be open. And AB point job setting. The default channel is 8. And the swath and speed. Swath means banner, that is U-shaped traverse distance. That is 6 meter is recommended for 10 liters drone. Speed, the maximum speed for AB operation. Next, output mode, that is called fence mode. First one is height limitation, and then distance limit and trigger behavior. The height limitation is used to limit the flying height of the drone. We can set the height of the fence and turn the height limit function on and off. Second one is distance limit. This distance limit is used to limit the horizontal distance of the drone. We can set the radius of the fence and turn the distance limit function on or off. Finally, trigger behavior. This is the behavior of the drone after reaching the fence boundary. Next, expansion module settings. It includes terrain following radar, obstacle avoidance radar, K-box status and readings, RTK reading and parameters. That's all. Okay guys, as we reach the end of this video tutorial, I hope this tutorial has been helpful in expanding your knowledge and skills in agriculture drone. Thank you guys.